base 5 of 0.4 is? Log base 5 of 0.4, 04 is it?
0.4.
Make sure I get all zeros in there. That's equal to something. Anybody want to give me a thing to stick there? Not a number, but like a letter or something? Pick a letter. You like X? Okay. I can figure this out by changing from logarithmic form to exponential form. So exponential form will look like what?
5 raised to 0.04. Or
No.
base x
5 to the x
equals.
is equal to 0.04. Now, because this is before I taught you how to do a change of base, somehow 5 to the x is going to have to equal 5 to something, which is going to be what 0.04 is. 0.04 is going to have to equal 5 to some number. And everybody has some really crummy looking ones of these in their homework. And I apologize now. If you have log base 2 of a 0.25, you got an easy one because that's just 1/4.
Yeah.
Well, what's this in terms of 4? What is it in terms of 5? It's not 1/5. Is it 2/5? Well, it's 4/10. Oh, it's 4/100. So it's, but you can just check a few. You know it's got to be, is it going to be a positive or negative number? It's going to be negative, right? Because this is less than 1. So, what do you want to guess? Anybody want to pick one to guess? You want to guess -2? So let's try. 5 raised to the -2 is, hey, 0.04. So, this is 5 raised to the -2. So, since our exponential is a function, 5 to the x is the same thing as 5 to the -2. That means x must equal -2. That's not one of the best ones to do this on, but it's one that's not so bad. These two, for most people, are really crummy because they're numbers that you may or may not recognize. But keep in mind, it's going to be some nice negative integer.
So we have to just guess until we find out what's right.
For the ones like that. But keep in mind, it's a nice negative integer. So somebody who, I don't remember who it was, may not even been in this class, but somebody emailed me and said, well, what's mine? It's like, well, you know it's going to have to be 8 to a power. Because theirs was log base 8 of some really disgusting looking decimal. And so, think about it. 1/8, you should know what it looks like, approximately. Yeah, it's like 0.1125. So 1/8 squared, you may not know, so you can try 8 to the -2, or try 8 to the -3, or in his case, it was 8 to the -4. But you won't have to go much past that, because this has some really icky ones. I don't like these as much as some of the others. So like, I'm okay with log base 4 of 32.
Can we do the third one? The rad?
Sure. So, and I don't mind this one either. So this is log base 625 of the square root of 5. Yes. And that's going to equal something, yes? We'll call it x again, just for fun. If I change to the other form, what will I get? Well, I'll have 625 to the what? X equals, what's another way to write the square root of 5? 5 to the 1/2, because it's easier if I can compare exponents. But this is 5 to the 1/2. Can I write this as 5 to something? And hopefully you're looking at me going, because I said this is one that you probably ought to know and recognize at least as being 5 to a power. 625 is 5 to what power? I think it's 5 to the 4th too. So this should be 5 to the 4th power raised to the x is equal to 5 to the 1/2. When I raise a power to a power, what do I do to the exponents? Multiply them. So this is 5 to the 4x is equal to 5 to the 1/2. And I'm not going that far over on the board, so we'll come over here. We'll work our way backwards. Since I've got 5 to a power equals 5 to another power, the powers have to be the same. That means 4x is going to have to equal 1/2. So how do I find out what x is? Divide by 4. So x must be 1/8. So this answer would need to be 1/8. Now with what we learned on, what's today? Monday, today's Wednesday. You could actually do all of these by using the change of base formula. But at the time that I taught you this, you could do them all by just changing to exponential form and understanding that's what you're going back and forth from and to. Where is the one that has like 7 to the log